The idea of this video is if you've been working on this problem about Cynthia and her daughters, you've read it, you get it, but you're just stuck. My goal with this video is to give you a hint to push you in the right direction, or if you've already started and you're like, no, this doesn't seem right, to verify maybe you're on the right track. So it's definitely my recommendation that you wait to watch this video until you've started the problem, till you have a good grasp on it, till you've tried to get your hands dirty with solving it. Of course, you don't have to. I mean, you can check this video out anytime you want. But if you really want to get a little bit more problem-solving experience, you've got to get your hands dirty. And if you haven't done that yet with this problem, watching this video will give you take that away from you. Take that away from you. That's close enough. It'll rob you of that opportunity to just get started on it yourself. So my recommendation, again, if you've gotten your hands dirty, you've written a bunch of stuff down, you're just stuck, check this video out. Maybe it will help. If you haven't started this problem yet, I wouldn't watch this video until you have, because you'll get more out of the problem-solving process if you try to do it on your own first. So that said, here we go. In this video, I want to go through the problem, that first problem I want you to solve that I want you to write the paper on. Now, if you're looking for what I want you to write, you want to check out the other video on the rubric. This is where I'm going to just go through the problem, see if we can get some first steps, and see what we think. So let's read it first. Cynthia has agreed to go on a date with Jonah if he can figure out the ages of her 3 daughters. They are counted as whole numbers, e.g., for example, no 6.5-year-olds. And Cynthia's only children are her 3 daughters. Okay. Cynthia says, I love my daughters. I always thought I wanted a son, but it just wasn't meant to be, I guess. I heard you like math, so I'll tell you the product of my daughters' ages is 36. Jonah says, that's not enough information for me to know their ages. You're going to have to give me something else. Cynthia says, I would tell you the sum of their ages, but you still wouldn't be able to figure it out. Jonah says, just one more hint. Cynthia says, well, sometimes I wish my youngest daughter was closer in age to her older sisters. Jonah says, I've got it. From this conversation, I want to figure out how old are Cynthia's daughters, and then make sure I defend my answer, right? Show why it has to be right. Okay, so let's make sure we've got the key points here. So we are looking for ages of the 3 daughters. Wow, I bet that's totally unreadable on a YouTube video. Bad enough that text is small. Ages of the 3 daughters. Okay. Ages, 3 daughters. They're counted as whole numbers. Okay, good. So whole numbers. And she only has 3 daughters. Okay. Just 3 daughters. So ages, whole numbers. And 3 daughters are her only children. Great. Cynthia says, I love my daughters. I don't know that that's important for solving the problem, so I'm not going to underline it. I always thought I wanted a son, but it just wasn't meant to be, I guess. It's just reiterating, just daughters. I heard you like math, so let me tell you, the product of my daughter's ages is 36. Product is 36. Okay, let me get that down. Product of ages is 36. Okay, good. Jonah says, that's not enough information for me to know their ages. Maybe we want to verify? So, not enough? Right, because if it was enough, then we wouldn't have to do anything else, just because Jonah says he can't figure it out. Maybe we could. Okay. Cynthia says, I would tell you the sum of their ages, but you still wouldn't be able to figure it out. Could tell you the sum, but you wouldn't be able to figure it out. So Cynthia says the sum of ages is not enough info. Okay, that's weird. Should probably verify that too. Jonah says, one more hint. And then Cynthia says, sometimes I wish my youngest daughter was closer in age to her older sisters. That doesn't seem relevant. Right? Sometimes I wish my youngest daughter was closer in age to her older sisters. But that's enough for Jonah to say, I've got it. So, younger, wish younger was closer in age to older sisters. Okay. Again, weird, but let's get it down. So, we've got 3 daughters. We know their product is 36. We're not sure if that's enough information. Cynthia says the sum of the ages is not enough. And Cynthia says she wishes your youngest daughter was closer in age to the sisters. All right. So, again, 3 daughters. And their product of ages is 36. Now, product. Remember that product means the answer from multiplication. So if I multiply all 3 of the ages together, I get 36. That tells me it'd probably be helpful to know what numbers multiplied together give me 36, right? In order to figure that out, I think it's worth doing one of these prime factor trees. Now, I don't know if you've ever done one of those, and it doesn't really matter if you have or not, but this is a way to figure out what prime numbers multiply together to give you 36. So 36 from this tree is 2 times 3 times 2 times 3. Okay, those are the prime factors. Now, it's also true that 1 is a factor of 36, so also 1s. So I need to figure out what are the different combinations that could have a product of 36. Well, so age 1, age 2, age 3, and I really only care about where these are different. So let's see. If I try to make the first one smallest, 1, 1, 36. I guess that could be their ages. So we have no idea how old anybody else is. 1, 2, 18, right? One, 3, 12. 1, 4, 9. Let's see. So I've just been holding the first one constant. The second one I've been going up by 1 at a time, but it's not divisible by 5. It's divisible by 6. So 1, 6, 6. 36 isn't divisible by 7 or 8. It's divisible by 9. 1, 9, 4. Okay, I've already got 194. So I think that's all my possibilities with 1 in the first spot. Let's see about 2. So 2, I did all the 1s. So how about 2, 2, 9, 2, 3, 6. If you haven't noticed, I'm making a table of all the possible solutions. 2. So it can't be 4 because 2 times 4 is 80. It's not a factor. It can't be 5. It can't be 6 because I've already got 2 and 6. Okay. So how about 3, 3, and 4, right? I must not have that one yet. 3, 4 would be 3. I already have that. 3, 5, 3, 6. Would give me smaller numbers. I think maybe I have it because there's not a 4 and higher. 5, 6 would be 6 and 1, or 1 and 6, which I have. So I think I've got all the possible combinations here. Okay. So product of their ages is 36. Here are all the possible ages. Now, what was our next hint? Our next hint was she could tell us the sum of their ages, but it wouldn't be enough information, right? So sum isn't enough? Question mark? But we don't know what the sum is. But I guess since we have all the combinations, we could find all of their sums. And then maybe something would start to click. So I'm going to actually leave this video here. I think this is a good start, right? We got a bunch of combinations that multiply together to be 36. Maybe finding the sums of them would be a good next step. I should have put a disclaimer that you shouldn't watch this video until you're ready to like get a hint. Oh well, I'll add it in at the beginning really cleverly, I'm sure. Watch for that once you've watched through this video. Thanks, and email me with questions. If you've got an idea but you're not sure if it's a way to go, shoot me that in an email, and thanks for listening. Now I need to find screen recorder and hope that I can stop it.